Going in here, there's a mirror. The mirror mirrors it out here. There's a second mirror in here. It goes into this little housing, and then there's a third mirror, and it gets mirrored down onto the material through a lens and concentrate a little more, and then it becomes really hot, and whatever the laser hits evaporates. It's like a ray gun from, I don't know, Star Wars.
So, I guess you could call it the laser cartridge. Do you have to replace it?
No, it should last for a number of years. There's nothing to replace here, except for we found that the lens, every so often it needs to be cleaned. And if we forget to clean it, it gets hot and then it cracks and then we need a new lens. It's a tiny thing, it looks like a dime, and it costs $250. And now that we know that can happen, we clean it more often. We hope that it doesn't happen again, because other than that, nothing but electricity. We only have to pay the electricity bill, and that's what's running the machine. So it's a very nice and cheap machine to operate. Let's see if I can get it to do something.
Someone you should have to move down this area as well.
Okay, it's actually not doing what I wanted it to do. I am going to do this again.
It's making sound, so that's it.
Well, that's better than it's not.
I have some black lines in here, and I want to have only red lines. All right, so let's try it again. One more second here. It was rastering. The laser was running back and forth, and then you don't really see the laser light. I want to actually show its teeth. Let's try it again. Yeah, now we can walk around a little bit so everybody gets to see it.
Oh yeah.
Oh my gosh. It's amazing.
You want to see that?
It's right underneath the little label that says, "Don't look at this." So laser cutters, they are super nice because the water jet, the diameter of the water coming out the nozzle is 0.7 millimeters, but the laser is much finer. The laser diameter, the beam diameter, is only 0.25 millimeters. So that's super fine. Plus, when it cuts, it actually melts the surface, and when it comes out, it looks glassy. It's beautiful. It makes beautifully nice cuts. When you order a custom aquarium from a place that is selling plexiglass, they use laser cutters to make parts, and then they use chemical welding like we have in a cabinet over there to fuse the things together. And people who are skilled, like our engineering physics students when they're coming out of the program, they make beautiful things. They look fantastic. They can do very artsy and very nice looking things that are also done right in an engineering kind of way. So yeah, this is the laser cutter. I'm cutting the UBC coat of arms, which as a part to cut on a laser cutter doesn't make any sense because there's too many lines in there and you can already see it all falls apart. It's like loose things, but it's still demoing very nicely how a laser cutter cuts. Say again? Well, I know some pretty complicated ones. The UBC one is not that bad actually. So yeah, this is the laser cutter. The same deal here. When people get to use it, we show a few students, and the students teach each other how to use it. And so far we've had good experience with this machine. Nothing has happened. If somebody was to open the door, it would turn off automatically, so this is a relatively safe machine. Compare this to a table saw. We do have a woodworking shop in Turkey, but we don't let the students use the table saw in that because it's way more dangerous than laser cutting. So, 19 already, time flies. I guess, any questions here?
How much is this?
How much the machine costs? $25,000.
Want to buy one? We can buy one. If you want to pitch in, we can buy one.
It's not actually that expensive. When you have a machine like that and you're a company operating in company ways, what we look at is how much do you pay per thing that you make. And a laser cutter like that can last 10 years. So then your $25,000 are only 2,500 per year and only a few hundred per month. And if you make 1,000 parts a month, then a few hundred is divided by 1,000, and suddenly the $25,000 becomes pennies per part. And that's what we look at as an operator. That's why these machines are so tempting to buy. They are very nice machines. Alright, I'm actually going to interrupt the thing now, and then we are going to move on. Sorry, laser cutter.
Sorry, laser cutter.
And then we're going to move on to the Hennings building.
What's the material on the bottom?
The material on the bottom is this. It's aluminum honeycomb. Funny you would ask, we actually have to replace that because every so often that gets worn, and it's just aluminum, and it's very thin-walled aluminum that is in like a honeycomb. So when the laser hits the top, it just gets deflected and it gets essentially let through, and it doesn't have enough power to cut this. But it slowly wears it down. It gets less and less, and then it becomes, it's a little lower here than there, and that's not desirable. That's why this has to be exchanged every so often.
Is this pure aluminum?
I don't know, it's some alloy of aluminum. There's very little pure aluminum out there.
Oh, it's work.
Oh, look at that, a useless coat of arms because it's falling apart. But yeah, you can kind of see. Oh, I got a U and I got a B here. Oh,
You, I'll take the U, the V and the C.
for Colombia.
Yeah, I'll
Alright.
take the U, the V and the C.
Okay, so that's the laser cutter right here.